Hello and welcome. Today, we're diving into Achievable and Repeatable Color, a guide to digital standards. In this session, we'll explore the role of physical standards, their limitations, and how digital standards can help ensure consistent color communication across the supply chain, no matter the print conditions. This is the fourth webinar in our six-part series, designed to help print and packaging professionals improve color accuracy. I'm Ed Hattenberger, Senior Color Scientist at X-Rite, and I'll be guiding you through today's discussion. If you have any questions along the way, feel free to submit them using the chat function. I'll answer as many as possible at the end, and if we don't get to yours, an X-Rite team member will follow up afterward. Let's get started. Let's start by taking a closer look at your supply chain. Where does color go wrong? At the beginning of any print project, the desired colors are specified, but sometimes those colors aren't clearly communicated throughout the supply chain. Other times, they simply aren't achievable with the chosen inks or substrate, but they're used anyway, resulting in less than ideal outcomes. At every stage of production, unclear color descriptions or material limitations can cause shifts in color, leading to frustration and disappointment. However, with better planning, achievable color specifications, and clear communication, you can create more predictable, repeatable results. Now, let's explore the common sources of these challenges and how to solve them. Let's talk about common physical guides and the important role they play in color selection and design. These guides are essential tools for ensuring color accuracy throughout the print workflow. They provide reliable references that help align creative intent with production reality. First, let's look at fan decks and printed guides. These are created under highly controlled conditions to ensure precision. Whether you're working with Pantone libraries or custom brand colors, these guides offer a comprehensive palette for designers to choose from, making them a cornerstone of the design process. Next, we have ink room proofs, also known as drawdowns. These are often produced in limited quantities and printed on the actual substrate intended for production. This allows teams to simulate the final production environment and serves as a critical checkpoint before the printer runs the color for the first time. Finally, let's consider light standard dark guides. These guides represent acceptable ranges of color lightness, offering flexibility while maintaining brand integrity. They're especially useful for managing the slight variations that naturally occur during production. While these physical tools are useful, they do come with limitations. Let's take a closer look at their challenges and how digital standards can help. While physical color guides are incredibly valuable tools, it's important to recognize their inherent limitations. Let's explore some of the key challenges they present. First, there's the issue of variability in production. Fan decks and printed guides are created using printing presses, and while the process adheres to tight tolerances, it's impossible to eliminate slight variations. This means no two guides are ever perfectly identical. Next are the challenges with ink room proofs. In addition to inconsistency from proof to proof, these proofs often show uneven color application across the sample, which can make them less reliable for consistent quality checks during production. Another important consideration is the inherent subjectivity in light standard dark guides. It's important to remember that the light and dark examples represent the boundaries of acceptable color, not targets to aim for. While interpreting any physical proofs involves a degree of subjectivity, relying on the light and dark samples can often introduce additional inconsistencies during production. Lastly, physical guides are susceptible to wear and tear. Over time, factors like fading, abrasion, fingerprints, and dirt can diminish their accuracy and reliability, making it difficult to trust them as precise references. To address these limitations, it's crucial to maintain digital color standards. These standards complement physical guides and integrate seamlessly with measurement instruments, providing consistent and objective quality control across projects. Let's talk about spot colors versus process colors and how the Pantone libraries play a key role in ensuring consistency. The Pantone libraries have been a trusted tool for many years. These libraries are available in two key formats. First, there are physical books, which are ideal for viewing and selecting colors during the design phase. Second, we have digital libraries, which are integrated into design applications, ink formulation, print production, and quality control workflows. Pantone also offers specialized color books designed for various printing needs. For example, the formula guides are dedicated to spot inks, which are custom mixed in an ink room. The Color Bridge Guide, on the other hand, includes both spot ink samples and examples of colors produced on press using a combination of CMYK process inks. It's crucial to use the appropriate library for your specific print process to ensure the best possible results. Now let's discuss an important point about digital standards. When working with Pantone, you should never measure printed guides to create digital standards. Instead, rely on Pantone's supplied digital standards. Here's why. The digital values provided by Pantone are the same benchmarks used during the production of their books. While every printed book will vary slightly from these targets, because that's just the nature of printing, the digital standards remain consistent. These are the targets that all the books aim to achieve, and they're what you should use to ensure consistency throughout your workflow. By relying on Pantone's digital standards, you're aligning with the precise benchmarks that ensure accurate and consistent results across your designs and productions. There is a concept known as the error stack, which refers to the accumulation of small color deviations at each stage of the production process, which, when combined, can lead to significant color inconsistencies. These deviations often stem from factors such as the use of physical standards, ink formulation, press operations, and substrate differences. On their own, these errors might seem negligible. However, when the final product reaches store shelves, the combined effect can create a noticeable and unacceptable difference in color. Let's look at an example to better understand this concept. A brand creates a vibrant new chip bag design and approves a master physical standard that perfectly captures their vision. However, when physical print guides are made for distribution, each one varies slightly. These physical print guides are then sent to multiple suppliers for manufacturing, and each supplier receives a version that differs slightly from the original master physical standard. At Supplier A, shown at the top, the physical reproduction of the standard they received has a delta E of 0.4. Their ink room measures it and formulates a matching ink, achieving a delta E of 1.1, and sets this as the new production standard. On press, operators work within a tolerance of 2 and are able to achieve a delta E of 1.5 when matching the new standard set by the ink room. From Supplier A's perspective, everything appears to fall within acceptable limits. Supplier B undergoes a similar process, but the physical reproduction of the standard they received has a slightly higher delta E of 0.6. The ink tech measures it, and despite their best efforts, the closest match they can achieve on their specific substrate is 1.3. They use this as their new production standard and send it to their press room, where the operators maintain a tolerance of 2 and achieve 1.3 delta E to the new standard set by the ink room. Again, everything appears to be within an acceptable range at Supplier B. The issue arises when these packages from Supplier A and Supplier B are displayed together on store shelves. Despite each supplier staying within their respective tolerances, the cumulative effect of these errors results in a delta E difference of 6.2 between the two suppliers' products. This significant variation means the packages look entirely different, which is something the brand owner cannot accept. The error stack highlights how even small deviations, when added up across a process, can lead to unacceptable outcomes in the final product. Let's take a look at real data from actual suppliers working with a consumer goods company. We analyze the exact scenario we just discussed. In this case, three different converters were aiming for the same target color. While each was close to the original standard, their results varied in different directions. Each converter established its own press standards based on what their ink rooms could achieve. Individually, their average delta E to their standard was quite low, meaning they maintained tight control over their own processes. However, when we compared the results across all three suppliers, we saw differences of up to over 3 delta E. This level of variation was not acceptable. So how do we control this? Let's dive into the solution. We recommend transitioning to digital standards rather than relying on physical chips. Instead of just using a physical chip, we measure the original standard that we've agreed upon. This digital standard is then distributed to all suppliers. Unlike physical standards, which can degrade over time, digital standards remain consistent. Digital standards should also go beyond just LAB values. They must include the spectral data from the measurement as well. This spectral data provides the most accurate and useful information for formulating inks. However, even digital standards carry some risk if they're not properly controlled. It's crucial to ensure you're working with the true digital standard, not one measured by an unknown or unqualified source. Once a digital standard is created and approved, that data becomes the definitive reference for that color. A common issue that can lead to invalid digital standards occurs when suppliers measure a sample they've produced or use some other book or sample as their digital standard. This will not match the original standard, which means the final product won't match either. Remeasuring the same physical standard over time to update your digital standard is also a poor practice. This method can cause the digital standard to shift in an attempt to match a physical standard that may have faded or become contaminated. There is an ISO standard that outlines how color data should be stored and exchanged. This standard is known as the Color Exchange Format, CXF, with CXF4 being the version that defines the data within these files. This standard is widely supported across nearly all modern color production software. At a minimum, it requires a measurement of the solid ink at 100%. Additionally, it specifies options such as including screen tint values and to provide the measurements of ink printed over a black background. Many large print companies have been distributing their digital standards for years, and most have transitioned to using the CXF format for color distribution. Let's talk about different types of standards you can create. Pantone follows a concept called the master standard, which many brand owners rely on to define their brand colors. Why? Because Pantone's printed fan decks provide a consistent visual reference. No matter where you are in the world, you can pull out a Pantone book, see the same color, and have a meaningful conversation about it. Printers and ink suppliers also recognize Pantone colors by their number, making it easy to communicate expectations across the supply chain. The colors in a Pantone fan deck represent ink formulations as they appear on high-quality, bright white, coated paper printed using an offset press. This means that if you're printing on a similar bright white stock using offset, flexo, or gravure, and if your inks can achieve vibrant results, there's a strong chance you can match the colors in the book. So, will this set of ink or color standards work for every print condition? What happens when you're printing on white or clear film with a white backer, or on folding carton board, or any number of other materials using different types of presses? Each printing scenario comes with unique challenges. Some inks need to meet specific requirements, like rub resistance, food safety, or fade resistance. And not all inks can reproduce the full range of colors with the same vibrancy. That's why understanding how different substrates and ink formulations impact color is key to setting the right expectations. This is where color matching challenges come into play. For example, I might be able to reproduce the Pantone master color perfectly on my customer's bright white cup. But what about the brown craft sleeve that wraps around it? There's no way to achieve the same color accuracy. Now, if I'm producing that sleeve at 5 different suppliers, each ink technician will work hard to get as close as possible to the target color. But despite their best efforts, none of them will match it exactly. Each sample they produce is the best they can achieve, the lowest delta E to my original green. The problem? These greens are all slightly different and in different directions from the original. So, which one is correct? I can accept that brown craft material won't allow a perfect match, but how do I determine which ink formulation is the right one? And what happens if I switch to a new supplier or print in a different location? What will their version of this color look like? Pantone Live introduces the concept of dependent standards, linked standards that have been tested and proven achievable across different printing conditions. With Pantone Live, every ink supplier works toward the same predefined target for the master color. This eliminates the guesswork and prevents wide variations in color across different suppliers. Instead of accepting inconsistent results, I can provide each supplier with a color target that is both achievable and repeatable under the specified print conditions. These Pantone Live colors are stored securely on a cloud server and are accessible through a subscription service, integrating seamlessly with various software tools throughout the supply chain. Let's recap what we've covered so far. Digital standards provide a clear and consistent way to define color, eliminating ambiguity and ensuring accuracy. Unlike physical samples that can fade or degrade over time, digital standards remain unchanged. Next, CXF files allow for the distribution of custom digital standards, but it's important to be mindful of the source. Inaccurate or inconsistent data can lead to unexpected results. Next, Pantone master libraries are a form of digital standards built on CXF, but instead of being manually shared, they are distributed through a cloud server. This ensures direct and seamless access within design and production applications. Lastly, Pantone Live takes this a step further with dependent standards. These provide achievable, real-world color targets for both the ink room and press room, reducing variability and improving consistency across different materials and printing conditions. When we start with a digital standard, or even better, a trusted dependent standard, the entire print process becomes more precise and predictable. Ink rooms can formulate colors more accurately, press rooms can achieve better consistency, and most importantly, every supplier, no matter where they are, will be working toward the same achievable color target. Looking at our chip bag example from earlier, by implementing digital standards, we were able to reduce the error stack from a total variation of 6.2 delta E down to 2.5 delta E. This level of consistency is critical when products reach store shelves. A brand's colors need to look the same, whether they're printed in one location or across multiple regions. Without a reliable standard, slight variations can create an inconsistent brand experience, which can impact customer perception. So, how do we put these standards into action within the supply chain? With Adobe applications, you can access Pantone Master Colors through the Pantone Connect plugin, which is available for download on the Adobe Exchange website. One of the best features of this tool is the ability to sample any color directly from your design file and instantly find the closest Pantone Master Color match. You can also build and share your color palettes in the cloud, making collaboration easier for your design team no matter where they're located. The Pantone Live license gives you a powerful tool to convert any spot colors defined in your Adobe Illustrator application or ESCO tools. This tool can be used to find the closest Pantone master or dependent standard to a custom-defined color, or to easily convert all spot colors from Pantone master standards to Pantone Live dependent standards for production. Another useful tool included with the Pantone Live license is the Visualizer. This tool allows you to view and compare how your selected color will reproduce across different libraries and substrates. For example, here we have selected the Pantone 485C Master Standard. In the lower right corner, you can see three different dependent standards displayed. The top one shows a carton printed on a flexo press with UV Cure ink on recycled board, and this standard is only 0.1 delta E away from the original master color. Below that, we see two types of craft paper, which are often used for bags or corrugated board. The brown craft is over 9 delta E from the master, while the white craft is under 5 delta E. If this corrugated box is going to be used for a point of purchase display, the print buyer may decide to use the more expensive white craft to improve the product's visual appeal on store shelves. Once the spot colors are decided, the ink technician will need to mix the ink. If a custom color standard has been defined, you can provide the color standard data in a CXF file to the ink room for use with their ink formulation software. If the colors are Pantone master or dependent standards, all you need to do is provide a list of the required colors, and the ink room will retrieve the standard data from the cloud. These digital standards contain precise spectral data, allowing the software to accurately match the colors using the appropriate ink colorants, tailored to the specific print application and substrate for the project. For the press room, digital standards are integrated into the quality control software, such as Measure Color or ColorCert, enabling press operators to monitor and adjust the color as they set up and run the job. So, with digital standards, you have a much higher chance of meeting the expectations of everyone along the supply chain. However, it's important to remember that physical standards still play a role. They're useful for designing, selecting colors for projects, and occasionally for communicating colors visually. But when it comes to actual production, it's crucial to rely on digital standards to achieve color consistency and accuracy from specification to production. That is the end of today's presentation. Now, let's take a moment to go over the questions submitted during the webinar. If you haven't asked a question yet, please feel free to submit it through the chat. I'll answer as many as I can, but if we don't get to yours today, one of our X-Rite color experts will follow up with you directly. Also, if you'd like to discuss your specific color evaluation needs, a survey will pop up right after the webinar ends. To kick things off, here's the first question. My brand colors have been used as physical standards for years in press rooms, but I want to switch to digital standards. How do I do that? There are two main options. If your colors are based on Pantone or are close to existing Pantone colors, you can specify the Pantone color name. If not, you'll need to establish a digital value. You can either request data from a print or ink supplier who has already produced the color to your approval, or measure an approved printed sample to create the digital standard. Once established, save the standard as a .cxf file and distribute it as your new digital standard. Suppliers should use this digital standard, not the physical ones, and you'll need to ensure proper management to avoid uncontrolled alternative versions circulating among your suppliers. The next question asks, I like the idea of Pantone dependent standards. What print conditions are available? X-Rite's website lists available dependent libraries, which are continually expanding. It also provides details on print conditions to help you choose the right one for your application. You can find this list on xrite.com by going to Products in the navigation bar, then Digital Color Standards, and finally, Pantone Live Library Specifications. All right, this is the last question I'll get to today. I have a file of Pantone LAB values, but it doesn't include all the new Pantone colors. Where can I get an updated version? X-Rite and Pantone haven't distributed Pantone color files in years due to control issues. Many files you will find were created by users measuring their own Pantone books, but these vary in accuracy due to condition of the book and the instrument that was used. Files from older applications may also have outdated values as Pantone colors changed periodically until 2010, and Adobe apps use data based on a UV cut filter, M2, that's not suitable for most print production. The best option is to use software that accesses Pantone Live cloud data, like X-Rite or licensed third-party tools. Most proofing software is licensed or has the option available. For Adobe apps, Pantone Connect or Pantone Live plugins are recommended. Okay, that is it for today. For those questions I didn't get to, an X-Rite color expert will be in touch soon. Thanks again for everyone's time, and please stay on for a quick survey. Have a great day.